Okay, so the lesson that we will have today is all about determinants, its properties, operations, and how we can apply its concept in solving the system of linear equation. Beginning with the determinant of a matrix. So what are the objectives? It is for you to find the determinant of a 2 by 2 matrix, find the minors and cofactors of a matrix, use expansion by cofactors to find the determinant of a matrix, and to find the determinant of a triangular matrix. Now, how do we define the determinant of a 2 by 2 matrix? So the determinant of a matrix A, which consists of the entries A sub 11, A sub 12, A sub 21, A sub 22, is defined to be the difference between the products of the diagonal entries. That is, you have your A sub 11 multiplied to A sub 22 minus, you will have your A sub 21 times A sub 12. So for example, we will have the following 2 by 2 matrices. What is the determinant of A? So obviously, the determinant of A is simply 2 times 2, that would be 4, minus 3, that would be 4 plus 3, that's be equivalent to 7. So the determinant of B is simply 4 minus 4, so that would be 0. And then for C, we will have 0 minus, okay, 2 times 3 halves, so that would be 3, or we will have negative 3. Now, what are minors and cofactors of a matrix? If A is a square matrix, then the minor M sub ij of the entry A sub ij is the determinant of the matrix obtained by deleting the ith row and jth column of A. The cofactor C sub ij of the entry A sub ij is simply the sign of the minor. So we will have C sub ij to be equivalent to negative 1 raised to I plus j times the minor sub ij. For example, find all the minors and cofactors of A. So since we have several A sub ij's beginning with A11, so in order to find the minor 11, we are going to delete the first row we're going to delete the first row as well as the first column, and we will be left with the submatrix that contains the elements negative 1, 2, 0, and 1. So the minor 11 is simply the determinant of the submatrix that is left after deleting the ith row and the jth column. So here we will have negative 1 minus 0 is equivalent to negative 1. To find the cofactor of 11, so we're done with finding the minor 11. How do we find the cofactor 11? So since this is just equivalent to negative 1 raised to I plus j, and since I is 1 and j is also 1, we have 1 plus 1 multiplied by the minor of 11, which is equivalent to negative 1. Then C11 is negative 1 raised to 2, that's positive, times negative 1, then C11 is negative 1. Now, how do we find, for example, M12 or the minor of the minor 12? Okay, so here we delete the first row as well as the second column, and we're left with the submatrix 3 that contains 3, 2, 4, and 1, so that the minor 12 is equivalent to 3 minus 8, that will be negative 5. And how do we find C12? So C12 will be negative 1 raised to 1 plus 2. So that would be I plus j multiplied by the minor, which is negative 5. So this is equivalent to negative 1 raised to 3 times negative 5. So that C12 is simply equivalent to positive 5, because this is -1 times -5 is +5. So you can find the rest of the minors and cofactor. So by simply deleting the ith row and the jth column and getting the determinant of the submatrix that is left and apply the and getting the cofactor, you simply apply the sign of the minor. So you have your -1 raised to I plus j. So consequently, if I plus j is an odd number, then the cofactor is negative. And if I plus j is even, then the cofactor is positive. Okay, so we will have the following minors as well as the cofactors. So in short, you can determine the sign of the minor, or that will be the cofactor, using what you call the checkerboard of signs, or the checkerboard pattern of sign. Say for example, we will have a 3 by 3 matrix. So say for example, we have a 3 by 3 matrix. If we will have here A11, A12, A13, and so on and so forth. Here you have A21 and then A31. Notice that with 1 plus 1, we will have an even power, that is I plus j would be even. And for 21, I plus j will be odd, so that would be negative. And then we will have here your 13. We will have here I, which is 3, and j is 1. So that would be 3 plus 1 is 4 even. So this will be positive. And you have here 12, which is odd. So this is negative, and so on and so forth. We can have the checkerboard pattern of signs. So you have plus, minus, plus, minus, plus, minus, and then you have plus, minus, plus. So that if you're getting, for example, the minor of, so you're getting the minor of 32. So you'll be able to eliminate the third row as well as the second column and find the determinant of the submatrix that is left. And so the sign, so the cofactor 32 is simply negative the minor of M32. And also with the cofactor, say of say 23, or say, no, let us say cofactor of 33. That is third row, third column. So this is obviously positive. So we will have positive multiplied by the minor of 33.